In this video of Introduction to Problem Solving, we are going to discuss algorithm, flowcharts and pseudocodes. First, we need to understand the steps for problem solving. Analyzing the problem, developing an algorithm, coding and testing and debugging. Now what is the first thing? Analyzing the problem. First and the foremost thing is, before we design a software or something, we have to analyze the problem before we start making the solution. So when we analyze that, then we begin to find out the solution. For that, what we are needed? Now we need a algorithm. What is the work of the algorithm? It is very essential, because from that algorithm we can write our programming code. Then after when algorithm is done, we need to convert that algorithm to a programming coding, and when the coding has been finished, the last thing is that we need to test it. Debug means if there are any errors on there, we have to remove those errors and again update it. Now we move to the first thing, that is called an algorithm. What is algorithm? Is a procedure or a formula for solving a problem. It is based on the sequence of a specified action. Perform activity by following certain steps. Sequence of steps. It works in a sequence. Now I will take one example. Make a cup of tea. How will Ravi do it? So what is the first thing? Step 1. Ravi will boil a cup of water in a kettle. These are algorithms in your own language. What is the next part? Second, add tea leaves and let them brew. We put the tea leaves now. Next step is add a milk to it, add a sugar, serve the tea. So these are the sequences 1, 2, 3, 4, 5, and that is the thing that we call an algorithm. We move to the flowchart. What is the flowchart is? It is a graphical representation of steps. It is again the same sequence we are going to work, but in this case we are going to draw the graphics, diagrams, different types of geometrical shapes which have different meaning. Now let us take one example first. Ravi brother wants him to make a cup of tea. Now we are discussing that thing in the case of both the things, algorithm also and flowchart. That how it is going to work, how we convert an algorithm to a flowchart. What is the first line? Ravi will boil a cup of water in a kettle. In the flowchart, we have to start with the top, this oval shape, and we have to write down start, then the arrow. This is called flow line. I'm going to tell you that also. Means the flow is going downward. And what is the first step? In a box, this is our rectangular box. This is called process box. Ravi will boil a cup of water in a kettle. It is a process. Second, add tea leaves and let them brew. This is again the second process. Add tea leaves and let them brew. Next, add milk to it, add sugar to it, serve the tea, stop. That means in a flow chart there is one start and one stop. Means here the sequence start from the start and it goes at the last and it is going to be stop. This is the work of the flow chart. That is, it is a graphical display of sequences. It is a simple language. We write down in our own language as steps. We need to move to the flowchart symbols. Now first one, this is our shape of a start and stop, and what is the use of this? It is used at the beginning and the end of the algorithm to show the start and the end of the program. Whatever we have written in the sequences, it is used that it is start from here and stop here. Next is a process. This rectangular box is being used for process. What are the processes are? Mathematical processes, means addition, multiplication, division, all the thing, initializations. This is our conditional box. Means if the condition is true or not, we have to move. If the condition is true, we move toward the right direction. If the condition is false, we move to the downwards. These are the lines, flow lines, that tell us that we have to move to this side or that side. It is used for input, read and accept. It is going to input the value. It is also used for output and printing and display also. Means this is the same box used for input also, and this is the same box used for output also. Means we are going to accept also and we are going to display also. In the case we have to use the same thing. Means it is used for input and output in both the cases. This is our connector. One page and off page. There are one page. This is This is connector, one page connector that connect two or more parts of the flowchart which are on a same page. Next, arrow or flow lines. You know that these are the arrow lines which show us the flow of our sequences. Start and stop. What is the use of start and stop? Use at the beginning and at the end of the sequences in a flowchart. Processing box. The rectangle indicate process like mathematical operations, addition, multiplication. Example like this: sum equals to a plus b or a equals to 10. These are the process box. These are the processes. Input output box. A parallelogram used for program input and output. We can use input, read, accept, and we can use output, print and display. The same box is being used for input also and for output also. I'll show that example also. If we input name, we use print name like this. If we input AB, we write down print. This is our output box and this is our input box. So the same box is used for input also and for output also. Now we talk about connector. This is on page connector. It connects two or more parts of the flowchart which are on a same page. This is very important. Same page means in a same page. On connector is being used with the letter that is A, B, C, D like this. And second is an off page connector. The shape is being changed. This is off page connector. This is on page connector. This is off page connector. An off page connector is used when the target is on another page. Means if you are drawn flowchart and the first page is finished, now you move to the second page, so you have to use the off page connector. It denotes by the character with the number A1, means A and page number from where the process continue. But this on page is being used in the same page. I'm going to show you the example also. Now the first example is for the on page connector. This is our sheet, red color sheet, one sheet, and in this sheet we are going to draw flowchart. And what is the example? That is, we have 8 steps in a flowchart. Sequence 1, 2, 3, whatever sequence are there. I'm just taking an example, and you have to draw a flowchart. So we start with the flowchart. Start sequence 1, sequence 2, sequence 3, and sequence 4. Now what happened? This sheet, this page is now been finished from here. Now we can turn the page and we can draw the next sequence 5, 6, 7, 8 there also. But in the same page you find out that in the right side so much area is being left. So we can utilize this area also. So now what we are going to do, we are going to use on page connector, and we put on page like this. A, alphabets have been used. We make a circle, write down the A and start the A again, and the 5, 6, 7, 8 all the sequences. This is called connecting. That here it has been finished, the fourth has been written. Now I make a circle. That means the connection is going to be moved to the top here, and now again the sequence is going to be start. That means the sequence of phone is now going to move to the 5, 6, 7, 8. This is called on page connector. Now we move to the next one, that is called off page connector. I'm take a same example. 8 steps are there. Now there is a page 1 and page 2. This is our page 1 and this is our page 2. Now how this off page connector is going to work? Now we start with the same thing. After sequence 4 page finish, and we don't want to draw in the same page, we want to move to the next page, we use off page connector. This is a line that is going to be, you need to understand, when we don't want to use the same page, we want to move to the next page and want to draw the other sequences there. Now there is no spaces left in the first page because page 1 is up to here only. This is the area of the page 1. Now what we are going to use, we are not supposed to use on page, we are going to use off page, and here it is. This is page 1 is finished and here is the page 2 is been started. Now you just go through that. Here I written A2 and here I written A1. So why I have written A1 here and why I have written A2 here? You need to go through the page. This is our page 1 and we move to the page 2. We write down that this is a connector. A2 means A is a label and this is our page number. Now you move to the page number 2. When I move to the page number 2, here is a connector again, and what this connector is going to say, that now the sequences are written in the page 2, but I am connected with the page 1. A1. A1 means page 1 and A2 means page 2. Means when you are in a page 1, you need to write down the number of the page that you have been connecting with the page 1. Means here my page is page 2. So I connect that with the page 2. If I write down in a page 3, so I need to put A3 here, and here I'm going to put A1. Then I'm going to connect that page. We have gone through all the things now. Now we need to understand one more question. That question is that write an algorithm and draw the flowchart from the given algorithm. If the question is find the square of a number. Square means we are going to multiply that number with the same number again. Means input a number and store a num. This is a sequence. Means we accept a number in a variable that name is num. Second, this is a line in a flowchart. It means to ask a number from the user and store inside the variable num. The variable is a storage place inside the memory where the number is going to be stored. This is a note that I have written hint. Afterwards, when you start the coding, you will understand what is the meaning of where it is going to be stored. Input, enter the number, comma, num. This is a line I asked from the user to enter the number and I'm going to store inside the num. So I converted this algorithm first line into a flowchart, this one. And what is this box is? This is input output box. When we ask for something or want to display something, in that case we are going to use this box, that is an input box. What is the next line? Now square. The number is going to multiply by number and store it in a square. Again, square is a variable that is going to store num multiply by num. So what is this? This is a process. But I have said multiply, divide, plus, minus is a process. So process is going to be inside the process box. This is our process box. And what is there? Square equals to num multiply by num. Now what is the next thing? We need to display it. Print square. And for this printing, we have to use the same box that we use for input. Print square. And what is the last thing? We put the start. We need to put the stop. What does it mean? That means this flowchart has been finished. This is sequence is finished here. So this is the example of question that finds the square of a number. Here I have written also, it is an input box, it's a process box, again it is an input output box. So you need to understand this and need to go through this and solve other questions also on the same basis of this question. If the question is to accept two numbers A and B, means now we are going to have two numbers A and B, and we need to accept the values for this, and we need to sum this and display. It is the same if you go through the previous one. You have to accept A and B, and A plus B is going to store inside the sum and display the sum. So what is the algorithm of the first is? We need to accept this number. So line is input number for AB. So here we write down input AB. This is our input box. What is the second step? Sum. Add A and B and store inside sum. So what is the line in a flowchart? Processing box. Sum equals to A plus B. This is our process. A plus B and it's stored inside this sum. What is the next line? Display the sum. Box that we are going to use, same this input box, print sum, then the process is going to be stopped. Means input, and for print we use the same box. Next again one more question is going to be there. Now let us solve one more question. Write an algorithm and a flowchart to calculate the simple interest, and the formula is SI equals to P into R into T divided by 100. We have to solve this question now. The first thing is we have to input PRT, then this is going to be the process, and then we display this SI. The algorithm is going to be input a number for PRT. In a flowchart we have put input PRT using the input box. Second is a process. What is that process? SI equals to P into R into T divided by 100. Here is the process and store inside the variable SI. So SI equals to P into R into T divided by 100. What is the next line? We need to print this SI. So last line is display SI. And here print SI. Print SI is being used and the start and the stop. So this flowchart is being finished, and these are the 3 lines of the algorithm, and this is the question that we have solved by using algorithm and flowchart.